So, ladies and gentlemen, you are welcome to my channel, Chemistry for POST-UTME and JAMB. So, we are going to look at some questions from POST-UTME. So, number one, calculate the volume of 0.5 mol per dm cube H2SO4 that is neutralized by 25 centimeter cube of 0.1 mol per dm cube sodium hydroxide. Option A, 5.0 centimeter cube. Option B, 2.5 centimeter cube. C, 0.4 centimeter cube. And option D is 0.1 centimeter cube. So this is actually a titration. We know that generally in chemistry, if we are going to do titration, we have a set off, and that set off is made up of burette, pipettes, and then of course you need an indicator. So you know that in chemistry, when we said an indicator, it means that it's any substance that can be used to detect whether a substance is an acid or not. So we use indicator in doing that. So, but in this case, it's a calculation that we are going to look at the concentration of, the volume of sodium hydroxide that is used during the titration. So therefore, to do that, we are going to apply a formula. But before we use the formula, first, we need to write the equation of the reaction. It's very, very important. We need to write the equation of. So in the equation of the reactions, first we have H2SO4 react with sodium hydroxide to generate salt and water. We know that generally in chemistry we have what they call neutralization reaction. And neutralization reaction is a reaction between acid and base to generate or to give salt and water. So therefore, this is an acid and this is a base. So at the end, after this reaction reach completion, we are going to have our acid, our salt and water. So therefore, in this case, in the neutralization reaction, what we are going to get is that this sodium will now replace the position of hydrogen. So therefore, we are going to have H2SO4 plus water. And of course, in this reaction, since in the product of the reaction at the end here we have to, it means that to balance the equation of the reaction, we need to add 2 hydrogen here. Sorry, we need to add 2 molecules, because here we can see that clearly in the product we have 2 molecules of sodium, and then of course this is 2 hydrogen and this is 2 OH. So we are going to add 2 here. So at the end here, it is very, very important to know the number of moles of the acid that is used, and then the number of moles of the base that is used. So the number of moles of an acid that is used is 1 mole here, and then the number of moles of sodium hydroxide that is used here is 2 mole. So therefore, we are going to apply a formula. The formula is CaVa all over CV VV is equal to Na all over Nb. The Ca here stands for the concentration of an acid, V here stands for the volume of an acid, Cv concentration of base, and Vb stands for the volume of base, and cost here stands for the number of moles of an acid, and here the number of moles of a base. So therefore, from the question here, we need to derive the we need to derive the data from the equation. So calculate the volume of 0.515. It means that the mole of an acid is 0.5 mole per dm cube. And then we have, and of course we have to calculate the volume of an acid, which is unknown. And of course the volume of a base is given, the volume of a base is given as 25 centimeters. And then we have the concentration of the base, which is 0.1 mole. And then of course the number of moles of an acid from here, it means that our Na is equal to 1 and our Nb, that is the number of mole of base, is equal to 2. So therefore now we are just going to substitute the value in the formula here. So therefore the concentration of an acid from the formula, we have concentration of an acid is 0.5 times the volume of the base, which is unknown, then times the concentration of a base, which is the concentration of a base is 0.1 times the volume of a base is 25, then is equal to Na. So the Na, the number of moles of acid is 1, and then divided by the number of moles of base, which is equal to 2. So we are now going to cross multiplication, and at the end we are going to make volume of base as a subject of the formula. So to make the concentration of to make the volume of a base subject of the formula, then we are now going to cross multiply and then divide both sides. Then at the end, we are going to have, after we cross, then we are going to have 0.5 times dV is equal to this times 2 is equal to 0.1 times 25 times 1. Then divide both sides by 0.5 times 2, divide both sides by 0.5 times 2. Then this one will cancel this. So at the end, we have volume of the base is equal to 0.1 times 2.5 times 1. Then we have, 0.1 times 25 times 1, we are going to have 2.5. Then 0.1 times 2, we are going to have 1. So this divided by this, we have 2.5 centimeter cube. So this is the answer. It means that option B is the answer for this question. And at the same time, we also have a formula for the dilution formula. We have a formula for calculating dilution, and the formula for calculating dilution C1 V1 is equal to C2 V2. This is a dilution formula we use to calculate the dilution. So that is the first question here. Repeating another question, which of the following is not found? Which of the following is not found in the nucleus of the atom? So generally we know that an atom, from the basic knowledge of chemistry, when we said an atom is the smallest particle of an element that can take part in a chemical reaction. So that is an atom. And of course, we have the structure of the atom. The structure of the atom is made up of a shell and a nucleus. So we have nucleus, and we have shell. So in the shell, we have electron, which of the following is not found in the atom? Which of the following is not found in the atom? Which of the following is not found in the atom? That is the question. So now we have shell, and in the shell we have electrons, and the charge of electron is negative. And then we have a shell. So a shell is, on the shell we found the nucleus, and of course in the nucleus we have proton and neutron. So proton is positive and neutron is nil, so it doesn't have charge. And of course in the shell of the atom we have different shell. We have K shell, we have L shell, we have M shell, we have N shell. So these are the shell. So in addition, the question is now asking us which of the following is not found in the atom. So we have electrons on the shell, then we have protons and neutrons. Means that we have electrons, we have neutrons, and we have protons. And of course, when we said a molecule is the combination of atoms. So when two or more atoms are joined together, they produce what they call the molecules. And we have different types of molecule. We have molecule of an element, and we have molecule of a compound. So when we say molecule of an element, it means that when you have the same atoms joined together, like for example, when you have hydrogen plus hydrogen, will give us a hydrogen molecule. So this type of molecule is called molecule of an element. So if you have molecules that have the same atom in it, so that type of molecule is called molecule of an element. And we also have molecule of a compound. So a molecule of a compound is when you have two or more elements that are of different types that joins to produce that molecule, and that is called molecule of a compound. Like for example, if you have sodium plus chlorine, then we have sodium chloride. So this is a typical example of molecule of a compound. So molecule of a compound is a combination of two or more atoms. Therefore, a molecule of an element, or in a molecules, so the molecules is not found in an atom. Rather, it's a combination of two or more atoms. So the answer is option B. It's not found in the atom. We are now going to look at the next question. So this is another question that we are going to look at. The question says the number of isomers, or the number of isomers that can be obtained from C4H10. And of course, from the compound here, we all know that when we have C4H10, from here we can see that in this compound we only have carbon and hydrogen. And from the basic knowledge of organic chemistry, remember when we said organic chemistry is the study of carbon and its compound. And this organic chemistry is divided into two. We have hydrocarbon and we have non-hydrocarbon. So hydrocarbon, it means that a compound that contains carbon and hydrogen only. Hydrocarbon is a compound that contains carbon and hydrogen only. And of course, you can see clearly here, this is C4H10. So therefore, this is hydrocarbon. And even within the hydrocarbon is divided into two. Said in organic chemistry. Organic chemistry is divided into hydrocarbon and non-hydrocarbon. So from here, when we say hydrocarbon, it means that when we say hydrocarbon, it means that a compound that contains carbon and hydrogen. Contain carbon and hydrogen only. Hydrogen only. That is hydrocarbon. So within the hydrocarbon is also divided into two. We have aromatic and aliphatic. And the aliphatic itself is divided into two. We have cyclic and we have acyclic. So when it's cyclic, it means that they are compounds that are in ring form. They are in ring form. You can produce something like this, like for example, this is cyclohexane, something like this, cyclobutane. So all these are examples of cyclic aliphatic hydrocarbon. So for the acyclic, they are the compounds that are found in linear. So aliphatic, they are found in linear. Or they are called open chain. They are acyclic, so they are usually in open chain. While the cyclic, they are in closed chain. They form a ring. So that is what we call aliphatic and cyclic and acyclic. So under this cyclic and acyclic, it is also divided into two. We have saturated acyclic, we have saturated, and we have unsaturated. So when you say saturated, it means that there are those compounds that have carbon 2. They are the compounds that have enough carbon, that have enough hydrogen atoms in them. It means that they are satisfied. So in them there is no any carbon to carbon single bond. Sorry, in them there is no any carbon to carbon double bond or triple bond. So all the carbon in saturated hydrocarbon all have single bond. Like for example, in this case, so that is why they are unsaturated. So example of the meaning of saturated is alkene. That is one of the member of saturated hydrocarbon is alkane. And this alkane has a general formula of CnH2n plus 2. So now, based on the number of carbon here, it tells us that our N is equal to 4. So we are going to see if with this formula we are going to achieve the same thing, that is to achieve C4H10. So now let's look at it. So here we have C4 H2 times 4 plus 2. So therefore we have C4 H2 times 2 is 8 plus 2 is 10. So we have C4H10. So it means that the C4H10 here is an alkane member. It means that it's an alkane member. Therefore, how do you calculate the possible number of isomers in alkane? But before now, we need to understand what is the meaning of isomers. What is the meaning of isomers? So when we said isomers, it means that they are compounds that have the same molecular formula but different structure. Now, compounds are compounds that have the same molecular formula different structural different structure. So they are a compound that they have the same molecular formula but different structural formula. And examples of that is, let's say we have C5H12. So in the case where we have this, we can have this compound can have a structure like this, CH3, CH3, and of course here CH3 too, then here CH3. So we count here, and of course it can be something like this, CH3, CH2, 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 and CH3. So if you can now look at this, you can see that here we have one. Let's count the number of carbon. We have 1, 2, 3, 4, 5. So we have 5 carbon here. Then hydrogen. We have 3 here. We have 3 here, making 6, making 9, 12. So they are 12. But let's look at this one too. We have 1, 2, 3, 4, 5. So we have 5 carbon. And then we have 3 plus 2, making 5, 7, 9, 12. So if you can see here, you can see that the number of carbon and the number of hydrogen are the same in these two keys of this structure, but their molecular formula is the same. So this is what we call isomerism. So isomerism is when you have a compound having the same molecular formula but different structural formula. That is what you call isomerism. So we have a trick of calculating possible number of isomers of alkenes. So if you want to calculate the possible number of isomers of 10 in alkenes, we have a formula. So the formula is here, is 2 power n minus 4 plus 1. So this n indicates the number of carbon. So it will give us an idea of the possible numbers of isomers of the members of alkene. So here we have the number of carbon here is 4. So we now have 2 power 4 minus 4 plus 1. So 4 minus 4, we have 0 plus 1. So any number raised to the power of 0 is 1. So we have 1 plus 1, making 2. It means that we only have 2 possible numbers of isomers that can be obtained from butane. So therefore, the answer here is option C. Okay? But this formula is not applied to all alkanes family. It's not applied to all alkanes family. Like for example, from methane to heptane. From heptane, you can use this formula. So if you use this formula from methane to heptane, you will get exactly the possible numbers of isomers of each of them. But in the case of octane, this is what we are going to use. In the case of octane, you use 2 power n minus 4 plus 2. So in the case of octane, this is the formula that you are going to use to give you the possible numbers of isomers. Like for example, in octane, the C8H18. So if you want to know the possible numbers of isomers of this, then we have to now add 2. Of course, the number of carbon is 8, then minus 4 plus 2. And of course, 2, we have 8 minus 4. 8 minus 4 is 4 plus 2. So 2 power 4 is 16 plus 2. So we have 18 isomers. We have 18 isomers of octane. So that is this applied to octane. But in the case of heptane, we use 2. Sorry, in the case of nonane, we use 2 power n minus 4 plus 3. So in the case of nonane, this is what we are going to use. So don't actually misplace them. So if you are able to use this, then you can be able to get the number of isomers of all the members of alkanes. Okay, so now we are moving to the next question. So now let's look at another question here. How many atoms are present in 6.0 gram of magnesium? Option A, we have 1.20 times 10 to the power of 22, and option B, we have 2.41 times 10 to the power of 22. And then we have option C, which is 1.51 times 10 to the power of 23, and then we have option D, which is 3.02 times 10 to the power of 23. And we have the molar mass of magnesium as 24, and then the Avogadro's number as 6.02 times 10 to the power of 23. So to calculate the number of atoms, we have a formula. We have actually a various formula for calculating mole. So, but in this case, we are going to use a formula which says mole is equal to number of atoms all over Avogadro's number. And the Avogadro's number here is 6.02 times 10 raised to the power of 23. So this is the Avogadro's number. So it means that here, specifically here, we doesn't have the number of moles, but we have the mass of magnesium, which is 6.02. So it's 6.0 gram. And then we have the molar mass of magnesium, which is 24. So we have to calculate the mole first. So how are we going to calculate the mole? So since we know the mass, we know our mass is 6.0. So we are going to apply a formula which says mole is equal to mass all over molar mass. Mass all over molar mass. So we have this formula. Mole is equal to mass all over molar mass. So therefore, the mass is 6.0. So we have 6.0 divided by the molar mass, which is 24. So this divided by this, we have 0.25 mole. So this is what we have. We have 0.2 mole. So we are now just going to use this formula. So the mole is already octane. So therefore we have our mole is equal to 0.25. Is equal to then the number of atoms. The number of atoms divided by 6.02 times 10 raised to the power of 23. So therefore now we have 0.25 times 6.02, that we have to cross multiply this time, this. So this time this we have 0.25 times 6.02 times 10 raised to the power of 23, then it's equal to the number of atoms. So if we multiply this time this, we are going to have 1.51 times 10 raised to the power of 23 as the number of atoms. So it means that the answer to this question is option C. The answer to this question is option C.